All right. So in the previous session, we were talking about loading various kinds of data. One of the kind of data was CSV. So you could load records. You could load records from the CSV, and either you could load data by handling one record at a time, okay, and then so either you could load a text file as an RDD and then run CSV loader against every record, right? If you look at closely, what exactly is going on here? Okay, so this function which you see here, load record, it takes a single line and then breaks down that single line into the CSV. That's what this particular piece of code is doing. So all you have to do is you import the standard CSV library of Python, and then you can convert the single record into the CSV. Okay, the important part you need to understand here is that the same process will also apply for the header of the file. If the CSV file is having the first row as header, that load record will be called against that also. Okay, so let's understand. So when we say sc.text file, so till this point we are dealing with this file as if it's a plain text file. So we load this file as a plain text file, and when we load something as a plain text file in Spark, what you get is a big RDD where every element is a single line, right? Now on every element you can run your logic. Now this logic could be your custom logic, or it could be using some basic libraries or some other libraries to do the work. Okay, and the important part to understand here is that this particular logic which will convert the plain text into the CSV record, this particular function will be executed in the cluster. Okay, so it won't consume too much of memory. So every time whenever we are loading this, every time it'll be only consuming the RAM equals to a single line. So the maximum RAM consumption of that computer on which this is maximum RAM consumption of any computer in the cluster will be equal to the biggest line you have. Okay, it won't shoot up, as opposed to imagine that this file is a 1 terabyte file where there are a billion records. Okay, meaning every record is a kilobyte. So if you load whole text file, it's not possible. Okay, it's not possible to load 1 terabyte file in any way using any tool in the world. If you have a really huge file, even let's say you have a 10 gigabyte file, 10 gigabyte means if each record is of 10 bytes, there are about 1 billion records in it. Or if each record is 10 KB, then there are 1 million records in it. So even loading 10 gigabyte using a really high computer is going to be a very tough task. But with Spark, you could load that whole text file, a whole CSV file on the cluster, and then convert each record into each line into a CSV record. And what's a CSV record? How does this conversion happen? It basically breaks down the line by comma and does some more magic. For example, in case the comma is surrounded by double quotes, then comma is considered as part of text, but not as a delimiter. So though that magic is happening by CSV dict reader. Okay. So you can think of it, if this input file contained a million records, this function load record will be called a million times. Similarly, dict reader will be called a million times across the cluster. Okay. All right. We have got a good question from Arpan. Okay. Let me see who can answer this question. Let me increase the font. All right. Now here's the question for all of you. Question is, how is my approach different from this? If we say text file equal to this, okay, okay. So I'll just write it down. Don't worry. So I'm writing the Python equivalent of that one, or we can say, you can say lambda line, and we say line dot split. Okay. Now his point is, Arpan's point is that what is the difference between this? His question is, his complete question is CSV dict reader is a Python method for Spark's wrapper method. Okay. Can anybody answer this? Yeah. So what is the difference between this approach? I'm talking in terms of the use case. Will both the results give you the same value, or will it be different? Anyone? There is a chance that all data get into the memory. But if you see sc.txt file, okay, all right. But in both the cases, in my approach as well as what Arpan has suggested, the approach is similar. Okay. Now Gridhar says this will split while loading. Okay. Okay, let me understand. I'm trying to understand this part. All right, now let me have a. Okay. All right. So that's Gridhar's answer. And this is from Srish. There is a chance that all data gets into. Not really. So if you look at this method and what we are doing, it's the same thing. You see, sc.text file, it's the same thing. It's just the way we are calling map. So effectively, what we are using we are using inbuilt function dict reader, while trees is basically splitting the data here. So the difference between my approach and Shri's is basically the difference is split here, and in case of in his case, in our case, we are using dict reader. Now let's see the difference. Okay, let me save it. Okay, so we'll say 23 Jan and Spark. Okay, Now here we go. All right. So imagine that you have a CSV file. Okay, you have a CSV file where data is like this: Sandeep, comma Giri, and then is a comma, and there is let's say there is 20, and there is let me try it out. It's a hypothesis. Okay, and I need to understand what happens in these cases. All right, everybody with me? So what exactly am I trying to say? What if my data is this? Meaning my data contains comma in it. Okay. Generally when you put comma here, so it looks like this. Okay. I want to see if my approach and his approach is same. All right. I have forgotten how do we. Okay. So if you see CSV, CSV dict reader. Okay, so it's a standard library where you can apply different kind of dialects and try to see if it is working or not. Okay, so we'll just simply try to put it in a record and then try to convert it record by record. Right, let's try the web console. All right, here we go. Font visible to everyone. Let's try with simple Python, or we can say PySpark, no worries. Alright, let me just create, should I create a file, text file? Alright, let me just try to create a file, my txt.csv. Okay, alright, and saying Hadoop fs copy from local my txt. Yes, CSV is separated by comma, but you see the double quote means that it's a part of the data. Alright, now we could say, let's say my raw data equals to sc.text file, and I could say my txt.csv. Alright, now you can see raw, and even for this, or we could say raw dot what do you say, collect, and see if it is doing anything. Good, it's working. Now you can see that string is starting from here going till here. You can see single quote surrounding it. Now so we have loaded this function, and next thing we will do is we'll create my function here, or here. Okay, I think this will work fine. Alright, let's just test. Did I do something wrong here? Isn't this correct? Alright. Yeah, that's right. There is a syntax error Yeah, this one. Good. Now load record. Okay, R equals to load record. Let me see if this is good or not. A comma B. Okay, so I forgot to import. Alright, let's import. Now again. Alright, what does it say? File stdin is not correct. But what is it, the mistake I'm doing? Alright, I think we need to provide the field names. Okay. Should I try again? Okay. So let me load this and try with, what was the line number? A comma B. Now you can see that it has converted it into a hash key value when we have provided the header information. Okay, so here you can see favorite animal is B, name is A. Alright, now let's try to do something more crazy. Okay, alright, it did not work. Alright, so at least it is understanding this part. So you can see if the data contains double quote, it's handling it correctly, it's removing the double quote. Okay, so that's one step. And while doing this, we could have said dialect equals to, here we could say dialect equals to Excel. I think that's the one which will do the job. Okay, let's try again and see what happens here. All right, I think we have to. This is correct. So I think the way we are formatting our data is wrong. Let me just open Excel and see how it's saving the data. Alright, I'm creating a new Excel. So I wanted to show you exactly is that using a given parser, a proper parser makes a lot of difference. Okay, All right, let's say I'm saying how, and okay. So here while saving, if I save it as CSV, let's say CSV, and we will call it we'll put it in downloads, okay, and see what happens. Okay, continue. All right, let's go to my terminal and then see how is it formatted. Okay, so you can see that okay, so it has put it in double quotes. I think if we also put our data in double quotes, it will work. All right, so let me try to put it in. All right, okay, so I've created the file, copied it into HDFS. I want to do it from HDFS instead of doing it from local. Okay, and let me just check if it is copied correctly. All right, here we go. What's going on? Oh, it has all kinds of records. Sandeep, double quote, and all of this. So let me just txt. Good. Now let's check if it is copied correctly. All right, great. Now, what I wanted to show you is this. Okay. If we use this technique whereby we are defining the load record and we are converting the text into CSV using some standard parser, then our results are far better. Okay, so that's the reason why I wanted to show you. Okay, so we can say data, so you can see data, and then let's see. Okay, and when we say map or when we say load record, all right, load record, or we'll just do the map. Output equals to what was the name of the RDD? Data. Then we do a map and we run a record. Okay, so now you can see output dot what do you say, take, or let's say take one. Wow, what a blunder. Am I not seeing people's question? What is happening? All right, so these are the questions. Where are the questions? Something is hiding somewhere. All right. Where is my questions window? Oh, here it is. All right. I think I got it. All right. So, okay. I think we are in the right track now. Now I can see everybody's questions and the question window. All right. So what we are talking about before on this disruption. So we were talking about why this would work. Okay. As opposed to, so the kind of data which I've chosen is this. You see this data from here to here. It doesn't have a new line. So here to here, you can see the record itself contain comma. In a comma separated file, if the record itself contain comma and we are simply blindly splitting by comma, then the record, you see, it will become two cells rather than a single cell. Okay, so that's one reason. That's one reason why we should avoid using our own parsers in the production environment. Okay, so that's what I wanted to demonstrate to you. And so we could say my txt.csv, and then on the txt-rdd we run map and we say load. Okay, and this is our out, and let's see if it works. Okay, so we could say collect, and then now you can see here. So here you see the okay, so let me just take both the data, that'll give you a good picture. So here you can see favorite animal, whatever. Now you can see here the name has come with the comma, right? And let me just take a step back and show you the actual content that we are trying to parse is this. Okay, now this is our input, and you can see that we have been able to successfully load it the way we wanted it. Okay, so the first record should contain the value which we wanted. Yeah, you can see name contains comma, it's the same one. Had we split it this the way we wanted, what would have happened is here we would have ended up with this kind of thing if we simply split. Okay, so we could have ended with this kind of thing. Okay, we would have giri here. All right, so that's the reason why we should be using this kind of approach instead of our approach. All right, is it clear to everyone? It's basically a difference of parsers which we are talking about. Great, great. So thank you again, Arpan, for the question. It's a good question, right? We should basically understand that part, that the whenever we have to parse in production, because parsing is always you know error prone, because even as simple as CSV file, it has so many edge cases. For example, what happens in the cases where the characters are UTF? What happens in the cases where the file, the lines are ending with slash r, not slash n? So there are many, many cases which need to be handled when you're building a parser. Okay. Therefore, it's generally a good idea to use a standard parser than inventing our own. That's why tools like tools like these, where we can basically use any library from Python, okay, Spark kind of a tools where you can use any library of Python, are wonderful because they give you enormous amount of control. If you don't like the output of one parser, you could have used any other parser. Okay. All right. How Gridhar, Sachin, Arpan, Shekhar, Shrish, everybody with me? Brilliant. Brilliant. Great. All right. So now the other way of loading CSV could have been a little lazy man way. Okay. Here, here the records are being loaded one record at a time by the CSV dictionary reader. Sometimes, sometimes this is what people choose to do. Okay. Where they use this whole txt file, and who can tell me what does the whole txt file do? Who can tell me this? All right, I give you a hint. So whole txt file, what does it do? Anyone? Arpan says it reads a directory. Brilliant. Okay. How also says that it loads all the rows. So it actually reads the whole directory. Now question is, when it reads the directory, what does each element of RDD contains? Yes. And the key is, yes. So it basically loads all the files in a folder. Imagine that, let's say you have a folder which contains the text files. Okay, hundreds of text files in a single folder. I think I would have some of the examples to show you. Okay, so let's try to have a look at it. I think I have something to show you. Where is you? All right, I think I have some data. Let me just take a look. Or maybe what I could do is something which you may like. Logs. Is that app logs? No. Yeah. Uh, no, that won't be a good idea. Let me go up. Apps data. Okay. Okay. So, all right. So, mm, okay, I'm not able to find it right now. I don't have. All right, never mind. So I don't have already data. Okay, can I just take the case of, no, I don't have a proper data. All right, I don't have good data available right now. All right, maybe I could just create a folder with a couple of files. Okay, let me just create Hadoop fsmkdir pig logs. Okay, and say Hadoop fs copy from local, and I say pig star dot log into pig logs. Okay. All right. Now let's have a look at what does this pig log contains. All right. So now you can see that the pig log contains how many files? 6, 7 files, 8 files actually. Now if we load, if we get here and we say r equals to, or we can say pig logs equals to sc dot whole text whole, what was the cases? Okay, let's just try. Okay, we'll say pig logs equals to pig log equals to, so it's continuously trying to do the garbage collect. I'm loading the full directory. Okay, so you can see pig logs and is let's say take 0, take 1. So you can see that the whole file has been loaded like an element, and you can see clearly that here it's a tuple. It's a tuple with two things. One, the key is the fully qualified URL of the file in HDFS. Okay, so when we said load everything from my directory called piglogs, where I have copied all my piglogs, the key is meaning the first value inside this tuple, which is the key of the tuple, is the location, and the rest is the data which is there. The slash n is new line. Okay, so now we have successfully loaded the data, loaded all of the data in pig logs. All right, parallelly. So this approach is great only when you have small file in each folder. Okay, when you have small files in each of the folders, then this approach is great. So what we have done is we have loaded the data. Now what we could do is each of the had these been CSV files, bunch of CSV file, we could have converted each of the CSV files into records, and instead of doing map we could have done flat map, so that every file gets converted into multiple records. And therefore when we say flat map and load records, what would happen is all of the files will get merged into a single RDD, such that every record in the CSV becomes a element in the RDD. Okay, is this clear what's happening here? So this approach is great if each file which we are loading from a directory is small enough to be loaded in a single shot. Sounds good? Okay. All right, I could have seen the example chat. Okay, so reader basically returns the reader, and from the reader you could iterate over the records. Okay, so this reader is actually not an object, it's basically, yeah, you could see, yeah. So here it basically returns an iterator. Okay, that's why we are using flat map. So every time you load the records, every time you load the records, okay, what it does is it basically returns the returns the elements here. Okay, so what it does is for each of the file it's returning an iterator, and this iterator is basically representing multiple records, and therefore this flat map would convert our every file into multiple records, and therefore we are returning a reader. Okay, how does it make sense? All right. If we just returned here the reader.next, then in the output we will get only one line from each file, because every element in this RDD from here to here is an RDD. It will generate an RDD. Now this RDD, when in this RDD, every element is the whole file. And on whole file, we are running this function called load record. And this load record is converting the whole file into multitude of records. Okay. And flat map is basically converting the whole thing into one record at a time instead of one file at a time. Okay, now if the files are bigger, then this approach is bad, very bad, because this particular part will overflow. I mean, even this will overflow the memory, because it'll try to load the data into the memory and load the whole file into the memory and overflow. Okay, sounds good to you? All right. So that's the way. So we talked about two techniques. One, the whole file in a single shot, parsing the whole file in a single shot. This approach can be great sometimes when your files are small but too many. Okay, if your files are small and there are too many files, then this approach of loading the whole text file as a single element of the RDD is great. But if your text file, your CSV file is really huge, then this approach is not good. All right. I hope you are able to see the difference. Is everybody clear about the difference between loading the whole text file and loading the text file as for CSV conversion? Brilliant, brilliant. So everybody great. Now, in the way we loaded the data, we can do the same thing for saving the data. Let's say, and we can do it cleverly as well. If we want to, we could basically either write one record at a time, or we could write all the partitions in a single shot by using write partition, map partition. So now somebody was asking me that what is the use of map partition over map, right? Now this example is a very good example for all of you. So in case of map, what would happen is, let's say we have created this function which takes a record as an argument, converts it into comma separated, and saves it to the disk. Okay? Or this program could take multiple records as an argument and then try to save them. Okay? Now, if we run if we try to save one record at a time, what would happen is there'll be too many files while saving. And also the disk, well, when you save the data, it's generally great when you're saving bigger data in a single shot. For example, saving 1 kilobyte data will take equal amount of time as 1 MB will take. Okay, because the time is taken in seeking the location where to write, and therefore saving one small file and one bigger file would take the equal amount of time. Okay, that's why we are saying save all the records of a partition in a single shot. All right. Arpan's question is, map partition is per partition instead of a record, giving better performance. Yes, exactly. Okay, so you could also do map partition and save one record at a time. That will be fairly slow. Okay, again, big data is more about handling huge data, and even a single millisecond is a big deal. Okay, even saving single milliseconds, if the single millisecond is impacting many records, is a big deal. Okay, so sometimes you want to load the data in a Excel tab format. So in those cases, you can use Python's CSV library itself. Just that you can say, instead of saying dialect equals to Excel, you could simply say dialects equal to Excel dash tab. Okay. And while writing in the same way, you could say writer equals to CSV dict writer and say the dialect is this. All right. All right. So the next one, which is important, is the sequence files. Okay, sequence file is a very popular Hadoop format. So when people were dealing with trying to write various kinds of data into Hadoop, then the sequence file were the format was created. The sequence file format is fairly generic in nature. Okay, it has got some header, it has got records, and it can store all kinds of data, whether it's a music, whether it's zip file, anything it can store. Sequence file can store any format. It's a brilliant format to store data. It's basically composed of, so the other use case of a sequence file is that if you have many small files, If you have many small files, you could bunch those files together and create a sequence file. Just like you have tar file, you have sequence file. Okay, so it has got something called it can be a binary key value pairs. So sequence file format is, if you look at the sequence file format, is designed for handling the complex data. Is designed for storing many kinds of format. So there are sequence file converters which can convert any format to sequence file, many kinds of format, MP4, MP3, AVI, all kinds of file you can convert to the sequence file. Similarly, you could convert a full zip folder into sequence file folder, or a full folder into a sequence file folder. And what it does is, sequence file has some header, as well as it is basically seen as a big key value pair collection, where key is the name of the file name, and the value is the blob. Blob is big large object. So that's a sequence file. The quality of a sequence file is that the processing can be distributed. The sequence file can be easily broken down into records, where each record will be key and value. Okay. Sequence file has something called sync markers. They allow to seek to a point. Okay, so you can, unlike uh, unlike the normal files where you have to go record by record to seek nth number of record. Okay, here you can simply jump to a particular record, because in the header itself, sequence file has the information about what are the locations from where the records is starting. That is called sync markers. Okay, now because in the beginning itself, when looking at the sequence file, it can predict, it can simply jump at various locations. So each individual node, while loading the big sequence file, do not have to go through the whole file. They can directly load whatever they want. Okay, so that's a very big advantage of having a big sequence file. All right, so you can load data from sequence file in a very simple fashion. Okay, you could say data equals to sc.sequence file, give the file name, and then tell that the key is the key which we are loading the sequence file contains the key in the form of text, and the value is interactable. Okay, so that will give us the complete data in the form of a huge key value collection. And now on the top of this key value collection, we can run any map function. Similarly, if we have a big list like this, okay, we can save it as a sequence file. All right, so you can always imagine sequence file as collection of key value pairs. All right, you can always imagine sequence file as collection of key value pairs. Value could be anything, key could be anything. All right, so you can see that you can use the Spark to simply save this data as a sequence file. Okay, let me show you. So you could go to here. Let me exit it. There are a lot of memory consumption. All right. So we have an RDD, okay, and we are saying please save this file as a sequence file. What does it say? Cannot be used because libhadoop cannot be loaded. Okay, the output directory already exists. Okay, let me try to delete the directory. Hadoop fs minus rmr, or let's just create some other directory instead of deleting. I hope somebody else is not hurt. Okay, alright. So this has been, we have saved the data to this location. Let's have a look at it. Hadoop fs minus ls slash tmp, and then we have this. Okay, alright. So inside this folder, this file has been written. Okay, let's just take a glimpse of it. It'll look like binary format to us, but let's just take a look at it. It contains non-printable characters. You can see that. Okay. Alright. So we are able to save the data in a sequence file format. Good. Now, and also note that the sequence file format, while we were saving it, it saved the data based on the partitions. Okay. Whatever partitions we had, of the RDD. Okay, I'm trying to see what's going on with the RDD. You can see that there are how many? Two partitions, one from here to here and other from here to here. So that's what this uh, saving the data has done to us. Okay, it has created two files, one from here to here and other here to here. Okay, that's what it has done. Now let's try to load the data and see if we are able to. So we did this, loaded in this folder. Now we are saying load our data from this folder. Okay. Now F is something which we have loaded data into. Okay. Now you can see clearly. Here we go. Okay. Now we are saying f.collect. Alright. So we are back to where we started from. Right. In the same way, basically, the sequence file format is quite useful when we talk about Hadoop because the many kind of data, specifically when you have lots of files in a folder, you generally convert the whole folder into tar normally, right? If you have used tar, or the way we zipped all the files into jar by exporting from Eclipse. In the same way, if you are dealing with lots of small files in HDFS, it is wise to convert all the HDFS files into a single sequence file. Okay? Because sequence file has been optimized for MapReduce. Why? Because when you run MapReduce, there has to be some data transfer from one node to another. Okay? That part is very well optimized with sequence files. All right. I hope everybody is with me. Any questions at this point of time? All right. All right. I have to take a call urgently. Let me just mute you for 10 minutes. Or let's take a 10 minutes break now. Okay? Let's take a break for 10 minutes or say 15 minutes because I think I have some urgency. I'm getting a call. Okay? Back by 10 p.m. IST. Okay? All right, so I'm back. Is everybody back? All right. So can we start now? Okay. So Sri, Sachin, Arpan, Shekhar, Gridhar, how should we start now? Great. All right. So let's start. All right. All right. So let's start. So we talked about dealing with sequence files, and we also understood how to deal with normal text file, hold a full directory of text files, as well as we also talked about uh, dealing with CSV, tab separated. All right. Now, and we also talked about JSON file. Did we talk about JSON file? I think so. Okay. So we talked about JSON, we talked about CSV, we talked about sequence file, and we also talked about loading the text files. All right. Now let's talk about the object files. Okay. So object files are another form of the sequence file. Okay. And the values which we are writing to the disk are based on Java serialization. Okay. And whenever we Spark jobs are communicating with other Spark jobs, it makes sense to write data in the object file format. Imagine this, that whenever we, let's say I'm working in Python and you are working in Scala, okay, or somebody is working in Java. All right, there are three jobs in three different languages. They want to communicate they want to communicate or read the data written by one. Okay, so let's say Java job is running, and whatever output it gives, it writes to the disk in HDFS, and then you want to read the same thing using the Python code. Okay, so the most sensible thing to do in these kind of scenarios is to use object file. Okay, that's all. Okay, it can also be, it is basically in those special circumstances. All right, when you have large objects and you want to access the same object in different programming languages. Okay, it's great when is great uh, when dealing with Spark jobs, but it can be comparatively slow. Okay, so the way you can save something as an object file is using save as object file, and you can load something using object file on Spark context. Okay, so from your side, the most important part is from your side, there is no extra code required to save something as an object file. Okay, that is something very important. Although Although the Python wrapper is yet to be made available, while Scala and Java ones are already in place. Okay, I think it's now available in the newer version. Earlier it was not. So, uh, but in case of Python, if you are trying to communicate between multiple Spark jobs which are running, you could use pickle file. Okay, what is the objective of object file or pickle file is that any arbitrary object, a complex object, if you want to save, you can save it immediately. Unlike, let's say there is an arbitrary object and you want to save it as JSON, you have to translate the object into JSON and then save. All right. So in case of normal saving something in object file or pickle file, it's pretty straightforward. All right. All right. So we have already talked about pickle file in the previous slide. So Python, when we talk about serialization, like for example in C, we always talk about object files. If you want to save an object into the disk without having to convert that object into string, okay, that used to be an object file in case of C. The same thing is available in almost every programming language. Okay, so it's a basically in the same way the way C has object file format. If you remember that object file format when you used to create an object and just save it to the disk, in the similar way we have this pickle file format. Okay, similar to the Java object formats. So we have the pickle file format. Now it could be quite slow. So generally these both the formats, saving as object file and pickle file, is not really too much recommended. Okay, instead you should go with open formats such as JSON in case of complex formats. If it's plain simple tab separated or comma separate values, these are easier to handle. Okay, so a pickle file is something quite slow actually at times. All right, so when unless required because of interoperability reasons, do not use pickle file for saving an arbitrary saving the RDD objects. Okay, so instead use either JSON or CSV or tab separated or maybe a sequence file. All right, so yes, pickle file format is only specific to Python. But then if you save something in pickle file, it will be difficult to deserialize it in other languages. All right, the example you can see here, you could simply let's say you can create a temporary file. This is a standard way of creating temporary file. Okay, and we are parallelizing the range of 10 numbers, and the most important part here is save an RDD as pickle file. Okay, and similarly here we are trying to load the same file back and gathering the data. All right. Arpan's question is very good. Question is, any benefits of using pickle over Cairo or sequence file? Not much. Not much. Honestly, the only difference is in case of Cairo or sequence, you have to put a little bit, tiny little bit efforts to convert an object into the sequence file format, Cairo or protocol buffer or JSON. You'll have to put a little bit effort. Here you don't have to put any effort. You can just save a big object into the disk. Okay. If the performance is not a concern for you, then you can go with pickle file. Otherwise, avoid. There are better formats. Okay. All right. So far we have talked about how to load the data from known file systems. Okay. This the formats was varying. Sometimes you have to load the data from non-file system data sources. For example, you could load the data from Hadoop supported storage formats. Okay, one such formats we have already seen called the sequence file format. There are other or extensions of the input formats. You can anything, any file format supported by HDFS is also supported by Spark. That is a great thing Spark people did, that they took the basic RDD. Sorry, they took the they took whatever is available as part of Hadoop and then make use of the same thing. So, for example, in if you remember the key value pair input format, so all those kinds of input formats are well accepted in Spark. Okay, so many key value stores provide Hadoop input formats. Good thing which happened with HDFS and Hadoop was lots of people worked on different kind of input formats. Also note that input formats are part of MapReduce, not part of HDFS. Okay, so people have created different input formats. All right, so you can use those input formats happily with Spark. Okay. Also, there are other providers of data, including HBase, MongoDB. All of that can be happily accessed using Spark. Okay. Now, if you want to store the data in the form of Hadoop supported, okay, you could save some file as Hadoop file using save as Hadoop file and load it using Hadoop file. Okay. All right. So a little bit more details about Hadoop file. So let's say there is a file this path and we are saying use this particular input format. Okay, where key class is this, value class is this, converter is this, and so on. So if you remember, there were many kind of input formats, right? And one of such format could be the key value input format. If you remember that, key value input format. Now imagine that you have key value input format. You want to load the data which was saved using key value input format, right? So you could say Hadoop file and given the path, okay, given the path, you can load the input format class. Uh, okay, you can provide that, hey, this is my input format with which the data has been saved at this path. And if you remember while we were talking about Hadoop format, you always you provide the what kind of key, the data type of the key, and data type of the value you have to provide in the form of class names. Okay, so you could read Hadoop input format with an arbitrary key and value class from HDFS. Okay, from HDFS, a local file system available on all nodes or any Hadoop supported file system URI. Okay, so for so basically this is more or less using like sc.sequence file. Okay, because in sequence file also we were dealing with one of the Hadoop formats. Okay, and this Hadoop file function is a generic form of that. In case there are other kind of input formats, then you can use Hadoop file. Also, please note that it's a little older API. The newer API comes with new Hadoop file API. Okay, you can see that it's called new API Hadoop dataset. All right. So basically, if I'm not sure if you have dealt with key value input format. So whenever you define an input format, you also define the data type of key and data type of value, and that's why you see key class and value class. All right. All right. In the same way, the API had just changed because of the version number. For backward compatibility, they did not change the older API. Okay. All right. So you can basically read any file format provided by Hadoop in any of the supported format. All right. Now there is something called protocol buffers. Protocol buffers were developed at Google for internal remote process calls. Okay. And so, for example, GWT, there was a web toolkit from Google. It was using the RPC and was conversing in terms of protocol buffers. Okay. Okay. So I'll explain to you what does it mean. So protocol buffers is kind of a competitor for JSON and XML. Okay. So in case of protocol buffers, what they did was they realized that the existing systems, existing XML kind of formats were not efficient enough. The parsers were slow, as well as the way the data is saved also takes a lot of time. All right. So Google came up with their own data format called protocol buffers, and these are specifically suited if you are saving lot of objects of the same data type. All right. So protocol buffers were developed at Google for internal RPC. Okay. They were open sourced, and it's great only for structured data which has got columns or predefined structure. Okay, where we know that this data, let's say there are 1,000 objects of something that need to be saved. In those cases, it's good to use protocol buffers. But in case you have arbitrary objects, in those cases, the performance of protocol buffer is equivalent to JSON. Okay, it's around 20 to 100 times faster than XML, and the space is around 1/10. The space consumed by XML is around 1/10. It's defined using domain specific language. Okay, so what you do is you first create your object class. Let's say you want to transfer lot of customer object from source to destination, or you want to save thousands of customer objects. So you will first create a protocol buffer with the name customer and define what are the fields that it has. Okay, and then the protocol buffer compiler converts that protocol buffer into a class, or into basically a domain specific language, maybe Java, maybe C, maybe C++, and using that format it can save or load the data. Okay, all right. So now the okay, so let me dig a little bit more deep, because this is something everybody is confused at, and I'll like to explain a little bit more. Okay, so so the way you do is okay, I think I have created an example. I'll talk about the example again. So the process is you define a class. Okay, you say things like class X, and this is another object, and so on. You define the class. Okay, now this is like protocol buffer. So you create the class in protocol buffers that gets compiled into domain specific language. Okay, domain specific language. Okay, it could be Java. Okay, so same thing could be created in Java. I'll just try to, okay, so let me just make it look like Java. So this is your Java class created from it, and using this Java class you could use, okay, using this Java class you could compile it further. Okay, let's say compile and run. Okay, okay, so data, after compiling this class, you can load the data, or load the data into, and it will give you the objects. Or similarly, after compiling and running, okay, after compiling and running, or I can compile, okay, so let's imagine this. After compiling this class, you could use it for anything. So first you have this protocol buffer, we call it protocol buffer. Okay, we define anything you want to serialize, you have to first define it using protocol buffer, and then use the generated class everywhere else. Do not use anything else. Use this generated class to create an object and save it. Okay, so this is how protocol buffers generally behave. All right, all right, very good question, Arpan. The question is protocol buffer like Avro? Yes, exactly. It is like Avro. Define a structure and use different languages to compile and generate. Okay, and then there is this format from. what do you call, Facebook or Twitter. I think I'm forgetting the name. There is this service layer, Thrift, right? So Thrift versus Avro versus protocol buffers. There have been many comparisons. Okay, so protocol buffers is one of the fastest amongst most of this. All right. All right. Let's take an example. For example, let's say you want to transmit or you want to save person object. So instead of writing your code in Python or Java, you write your first object definition using protocol buffers. You write message, person, and so on. You write all the member function names. Okay. And similarly, let's say there is a subclass of person which is called phone number. You could define that also as a protocol buffer message. You can see the first one is a string, second one is integer, then string, then enum, then this object, and then there is another number. So you can see, here we are using the same class what we have just defined, or you could say address book, which contains repeated persons, meaning address book is collection of persons. Okay, so similarly, a person can have many phone numbers. And here, when you see equals to 1, 2, 3, it means is that this is the sequence order of the various values inside that object. Okay, no matter what happens, this first object will be the name, then second object will be the ID, and third object will be the string, and so on. Okay, so this is the standard way of defining a protocol buffer. Specifically, let's say you have a big object name person and you want to serialize them very quickly using protocol buffers. In those cases, you could first define the protocol buffer like this and then use it again and again. All right. The only downside is that you have to install protocol buffer compiler. Okay, and create. So this is a complete separate process. Whether you are coding in Java or you are coding in Python or you're coding some other language, you have to use protocol buffer to convert this particular class into the multiple language specific examples. All right. So you can see that we are saying proto C, meaning protocol buffers compiler, and input is this directory, output is this directory, and we are saying Python out. That means we want this to be converted into Python, and this is our input file. Okay, so this will generate the Python code. Okay, so let me see if I have protocol buffers. All right, looks like I don't. Or maybe on the server it should be. It should be on the server. Okay, let's try to see. Pip install. Alright, looks like it is not done. Alright, let me do SSH. Alright, E and H5 are the same thing. And let me just see if we have installed protobuf. All right, looks like pip is not installed. We'll have to work on it. All right. All right, let me try to install the protocol buffers. Okay, maybe tomorrow or later. All right. So basically the idea is first you install the protocol buffer compiler, then you install the protocol buff library of Python, and then you can start creating objects in Python, and then you start compiling, start serializing those. Okay. All right. So, okay. So Spark libraries for loading and saving both support compression. Okay. Because file compression is very much required in every case scenarios. And whenever we say, for example, we are loading a Hadoop file or a sequence file, we can specify that which codec do we want to use. Okay, we can specify that which codec do we want to use. All right, even in the input format here we can specify, and also here in the config we could provide that, hey, this data is compressed, so decompress it before using. Okay. So almost every format supports compression. All right. Specifically in Hadoop, there has been a lot of work done on splittable file format. Okay. If you remember that blocks, the data is stored in blocks in HDFS. Now imagine that there is a zip file which is stored as in blocks. Now, if you remember that zip, zip file, to convert a zip file or decompress a zip file, you need to gather all the blocks together, which is a major headache. Okay, it's not possible to gather all the blocks together in order to decompress, because otherwise the overall objective of using HDFS is totally lost. Okay, therefore, Hadoop guys worked a lot and figured out gzip splittable and Algedo. There are many formats that were invented in order to have a compression format which does not require all the files at once, all the blocks at once to decompress it. You can partially decompress the data. Okay, so that was the very important aspect of the splittable formats. Okay, if you remember our those days when we had splittable zip file, or there are many other formats, in all of those you have to gather all the zip files together, zip files parts together in order to decompress, which is not something acceptable. Imagine that if you have few gigabytes of data and you have put it into HDFS in a compression mode, every time you retrieve the file, if it has to gather the data from all the nodes, right, and then decompress, then the whole objective of Hadoop's MapReduce is gone. Because the reason why, because while we run MapReduce, it runs the logic near the block instead of transmitting it. If you start transmitting the blocks from here to there and there to here, all of them gathering at one place, then the whole objective of distributed computing is lost. And that's where the splittable formats come into play, so that each individual section of the data could be decompressed. All right. All right. So there are many compression formats, and here is a quick comparison amongst them. So you can see that the criteria which you should be judging a compression format is based on whether it's stipulatable or not. So while you are taking a call whether to compress the data, if so, which format should I be using or which codec should I be using, you always take a note of the splittable property. Okay, so you can see that although so one is whether the format is splittable in the sense that various parts of a zip file, can they be independently unzipped? Okay, that is splittable. Second criteria of a compression is how fast is it to compress or decompress. Next is what is effectiveness on text, as in, is it very high compression? Does it convert megabytes into kilobytes, or it just converts it into decreases by 10%? That is effectiveness. Effectiveness is generally measured against text file. Okay. And whenever we are using a Hadoop codec file loading the files, you could specify if you are inclined to use this ggip format, then you can say the codec equals to ggip codec. Okay. And similarly for bunzip, you can see Algedo. Algedo is very fast and effectiveness on text is medium, and this is the file. So generally you can see that Algedo is something which is considered good out of ggip, bunzip, or okay. So if you want very fast serialization, use Algedo. If you want very high compression, use bunzip. Okay, these are the two. And rest of them are non-splittable. Okay, rest of them are non-splittable. Okay, so Arpan's question is, what does splittable means? Okay, all right. I think I should take a step back and ask you a few questions. Okay, so if there is a big zip file, and you have splitted it into say 10 MB each. Okay, let's say a.zip.1, a.zip.2, a.zip.3, okay, and a.zip.4. Okay, let's say because you could not fit this data into your floppy drive, you have broken it into 1.44 MB each. Okay, so now these four floppies contain the data. Now whenever you have to uncompress this data, okay, if you want to unzip the data, what will you have to do? Yeah, yes. So what you have to do is you have to copy all of this data, all of this data to a place together, right? And then unzip it, concatenate and unzip it. Okay? Yes. But the beauty of let's say the same thing in Algedo. Okay? Same thing in Algedo, Algedo and Algedo. Okay? If you have this, you could convert it into individual part of the data. Okay, without having to copy it to the central place. That means that means that means if we could do this, then we could run individual mappers happily. You could run individual mappers happily, right? On individual parts of the data and so on, right? Make sense to you? Therefore, here our only, the important criteria is whether can you uncompress the part of the file without needing other parts? If yes, then it's not. Yeah, if you can uncompress part of the data without needing other parts, then it is splittable. All right. All right. The beauty of Bunchip is that you can just like you execute your jar on a Hadoop cluster without having to install it everywhere, right? The way we are running Spark, it automatically loads the jar on every node using yarn. In the same way, this bzip, or we call it bunzip, or for unzip we call it bunzip, and bzip is for compression, bunzip is for uncompression. So the quality of bzip is you don't have to install on every node, but ljedo you have to install on every node. okay, because it's a native command, while bzip is kind of a Java library, right? The only difference, the one which you need to notice, is that Algedo is fast, but effectiveness on text is not very high, while bgp is slow, but effectiveness is really high. So based on whether it is the time or storage, what is important to you, you can either pick Algedo or Bunzip. I mean bzip. All right. Now, reading writing from other file systems. You can loading and saving data from other file systems. You can load data from other file systems, and let's say, for example, if you want to read text file, you can simply read something like this. Okay. Mostly, if something is compressed, it will decompress it based on the codec available. Okay. So, all right. Now, what I wanted to show you is, in case you are providing this part, if you are providing your file location using file colon colon, it will try to read the data from the local machine. Okay. That means that this file, if I say here, if I'm here and I'm running PySpark, okay, and we say this file has to be available on the local node of this machine and all other machines on which this command get executed. Okay, so this particular file has to be available at this location on all the nodes in the cluster. If you are saying file colon slash slash, because it will be executed distributedly on the cluster. Okay, it has to be available on all the nodes in the cluster. Otherwise, if there is a file which is only available to you locally on this particular machine, what you could do is you could load this file into the memory and then do a parallelize. That way, the data which you loaded into memory, it will get loaded on the cluster. Okay, if you only have a file on a single machine, then prefer loading the data and then loading the data into the memory, reading the data into the memory, then converting the loaded data into a distributed file by using a distributed RDD using sc.parallelize. Okay. Next is Amazon S3. You can simply specify the file path, whether we are saying Hadoop file or text file. Anywhere, all you have to specify, the way you specified earlier, file colon slash slash, in the same way, all you have to specify is S3N. S3N colon colon slash the bucket name. Bucket name is the name of the bucket which you have defined in Amazon, and the path inside the bucket. Okay. All right. And the password, because most of the S3 content might be password protected. In those cases, you have to set these environment variable before loading data from S3. All right. Then is the HDFS, okay, the Hadoop distributed file system. All right. So, all right. So one more thing while talking about S3, as we have talked earlier in the great details, that the code is executed near the data. The same could happen with S3, provided you are using Amazon's EC2. Okay, if your nodes are inside EC2, then you can take the benefit of data locality. All right. Similarly, this is probably the most default one in case your Spark is either running in yarn client or yarn cluster mode. Then if you do not provide any path, as in if you do not provide any protocol, Hadoop thinks that you're talking about HDFS. Okay, and to take the benefit to take the benefit of data locality, the way MapReduce was taking the benefit of data locality, in the sense that you execute the code only on the machine where the data blocks are existing. In the same way, if you want Spark to take the benefit of data locality, you have to run Spark on the same node. You have to run Spark on the yarn cluster running on the same HDFS. Okay. So also note that whenever you're talking about Spark and Hadoop, make sure that you are running Spark which is compatible for that particular version of Hadoop. All right. All right. So we talked about many things so far. We talked about how to load data from various formats. Then we talked about how to load the data from various file systems, be it local file system, be it HDFS, and be it maybe HTTP actually for that matter. And you can load the data from many more protocols. Okay, you, so that was for unstructured data or semi-structured data. But what if you want to load data from sources like SQL? Let's say if your data has got schema and you want to load the data from, say, SQL, Microsoft SQL, or anything, you could use Spark SQL. And Spark SQL is quite powerful, as you will see in the upcoming discussions. All right. And all right, it gives back the RDD of row objects. Okay, so whenever you're using Spark, you could simply you would simply get a list of rows, and then you can on those rows you can start calling the methods. All right, you will see it as we go forward. We'll have a bigger discussion on Spark SQL. Similar to that, you could also load data from Hive. This also has been moved to Spark SQL. It's a very common structured data source on Hadoop. It can store tables in a variety of formats inside HDFS or other storage. And so if you already have created a structure over your HDFS data using Hive, then you can directly talk to Hive and load the data from Hive. All right. All right. Here's an example you may try how we are using SQL context to load data from Hive. Okay. most important part is that you have to copy the Hadoop site information or Hive site information into Spark/conf. Alright, and then you run spark bin spark. Alright, alright, let me pick up a question. Alright, this is Arpan's question. Alright, we need to register the df as a temp variable. Yes, that's for Spark SQL. We'll talk about it after some time. Okay, so question, I hope everybody got the question. Yeah, this is for Spark SQL. We will talk about it a bit later. Alright, I think a better idea would be to talk about how to load the data while we talk about Spark SQL, because talking to Hive directly has become a little old fashioned, and we will take it later point of time. Alright, similarly here we what we have tried to show you. So the way we are doing here is we are talking to SQL and we are selecting data from there. And once we get rows, then we can iterate over the rows and get the data. Okay. Similarly, here we are using something called Hive context, and we are loading the JSON file into a table, and then we are querying on that table. Okay. So we basically we are not only here we are not only reading data from Hive, but we are also executing query on Hive. All right. Similarly here, we are also here what we have tried to demonstrate is we've tried to load the JSON file into a table, and then we have registered it as a table here and then used it. Okay. So these are the things which we will discuss in detail when we talk about Spark SQL. All right. And most of it has been replaced with a data frame. All right. We will talk about these things. Or do you want me to give it a shot now? All right. It says no such table like employee. Okay, let's go to Hue. We already have Hue, and let's go to Metastore tables. Here, do we have any? We have employees table. Okay, we have employees table. So let's try with the employees table. Okay, this time it has done something. So it has loaded the data from, you can see that it has loaded the data from this location. Okay, you can, all right, let's, if you want to see what was the table name, employees. Okay, so we can say browse data. You can see that we have employee name, salary, degree, and qualification. This was our table, and we have been successfully able to read that. Also, please note that this table is actually a partition table. Okay, this table is actually a partition table, and still Spark has been able to talk to it happily. Okay, you can see that all the records have come here. No, actually it has only, okay, okay, it has only brought the data from the parts. All right, right. So it has been able to successfully read the data. Sandeep 10, Sandeep 12, Sandeep 12. All right, all right, all right. In a similar manner, we could also load data from JSON. All right. A better example would be that the other example which I would like to show you after this. Okay. So you could actually load, you could convert any JSON object into a table and then use the query over it. Okay. So the Hive context, as we all know that Hive you can load the JSON and then you can query. Similarly here in the Hive context, you could start querying over arbitrary objects like JSON. All right. Next example here is that we have tried to connect to the database directly using this driver library path. Okay, so let's say you have some SQL from which you want to import data to Spark, or you want to import data somewhere else. In those cases, Spark, you could directly let Spark talk to the database. All right, you could directly let Spark talk to the database. And the most important part here to understand is that you have to have MySQL connector. If you don't have the MySQL connector, Spark would not know where to find this particular driver. Okay, so you could contact any databases using the SQL context, okay, which is part of Spark SQL, and can talk to any of these systems and get the data. All right. So right now I do not have my SQL jar, but I can find it out. That's not a big deal. Okay. So I could say sudo find slash name, and I could say MySQL connector star.jar. All right. Let me just take it and keep it somewhere. Or let me just use this path while executing. Okay. Now let me just try to, okay, let me try to execute it this way. All right. So we have started with the library, and now we can basically, okay, here it'll be H1, I think it'll be H3, and will it be able to connect to mcs3.cloudxlab.com 3306? Good, it's able to connect. Okay, all right. So let's try to execute it. Most likely it's going to get password incorrect error. Okay, okay, it's getting password. Not no big data, we'll have to say CloudXLab. Alright, this basically will fail at the password, so I don't think it's a great idea right now. Okay, I think it will take a lot of time to connect because most likely the firewall is blocking it. Okay, so this is something, let me put it. Okay, this is because we have recently done some blocking of the firewall. So maybe this node may not communicate with the SQL. Alright, so that we will take care of it lately. Alright, so that was pretty much. The only thing which we have skipped today is talking to Spark SQL. Okay, alright. Two things we have moved to future. One is uh, one is talking about the Spark. One is the Spark SQL. Other is talking to MySQL from Spark. That is probably the firewalls issue. It's taking forever. That means it's a firewalls issue. You can see that socket is forever listening here. So it was stuck at the socket. That means the firewall had just blocked it. Okay. All right. So any questions at this point of time? I would like to move to Spark, advanced programming in Spark. So we'll talk about broadcast variables and shared variables. All right. How Shri Sachin Arpan Shekhar Gridhar, are you with me? All right. So here question from Arpan is how to load data from HBase. Good. How to load data from HBase. Okay. So let me make a note of it and have a running example which I can show you. Okay. So generally you can contact, okay, or maybe from Cassandra. Cassandra, yeah. So alright. So generally in most of the cases you could provide the protocol name such that it can directly talk to the Cassandra or HBase. But let me come up with a proper example and then that'll be easier for us. Okay. That'll be easier to understand. Alright. Okay, so let's talk about the advanced operations on the Spark. Yes, go ahead, Arpan. I'd like to answer your question. Okay, so all right. Arpan is saying I was trying to run a job in CloudX Lab but could not connect to 4040. All right. In that case, the URL which this guy is printing here, okay. Yeah, I forgot to mention to all of you. So whenever you are trying to run anything, okay, say for example this one, don't go with the this IP address. This is a private IP address. Instead, use either e.cloud, whatever domain name you are on right now, just put that domain name instead. Okay, because this is a local IP address. Okay, so if you do this, then it'll work. See that? All right. So if you are trying to, this is something I could have informed already. Okay. So whatever node you are logged in on, say I'm logged in on H5. So go to pick H5 and notice the port number here. Whatever port this guy is giving you, whenever you start Spark, it would give you a URL to monitor. Okay. It says started Spark UI at this port. So notice the port here and so copy it like this and say whatever port was there, you just put it. Okay. Also note that for each user, it creates a port starting with 4040. All right, everybody with me? All right, so let's take. All right, so let's talk about shared variables. When we pass functions to say transformations or any action, okay, every node gets copy of the variable. Okay, so every node gets copies of the variable. If you change the variable on that particular node, the impact will be only on that node. It does not get communicated back. Okay, the change in these variables. So if you think about the way it happens is we tell RDD that, hey, here is my function, run it on every node in the cluster. Okay, here's my function, run it on every partition. Now this function which we are passing to map, it might be having variables and it might be changing those variables, right? Or it might be referring to an external object which is a composite object. Now every node gets a copy of the variable. The change to these variable is not communicated back. Okay, it's like passing by value, if you remember passing by value. So any change locally happening on the particular node does not get communicated back. After starting of the map, changes to the variable on driver does not impact the worker. Okay, so any changes that happen inside a worker, they are not communicated back. There are two kinds of shared variables. One is accumulators for aggregating information, okay, and second is broadcast variables to efficiently distribute large values. Okay, so basically there are two kinds of shared variables. Number one is accumulator, in the sense that when you want to just gather the data from all the nodes at a place, you use accumulator. And in case you want to broadcast efficiently to the whole cluster, use the broadcast variables. Okay. All right. A quick question to everyone. Yes. So can you match AB with 1, 2? An operation is cumulative if 1 or 2. An operation is associative if 1 or 2. Yes. If operation is commutative, not cumulative. Operation is commutative. We have already discussed this as part of our while we were discussing the reduce function. Yes, Arpan. So match AB with 1, 2. How says B is 1, A is 2. Is that right? Arpan, Shekhar, Shrish, Gridhar. So commutative means 1 or 2. Are you sure, Shekhar? All right, that's correct. So good. So a commutative means A into B is equal to B into A. That's commutative. Or A plus B is equal to B plus A. While A minus B is not equal to B minus A. So negation or subtraction is not commutative. Same is the division. Division is also not commutative. All right. While associative is A operator B, then first you operate on AB, then you operate the resultant with C should be equal to, if you operate on B and C and then operate with A, it should be equal. All right. Yes, Sekhar, go ahead with your confusion. I'd like to make it clear. Yeah, yeah, you're right. All right, that's right. Okay. Thank you, Sekhar. All right. So I've corrected the answer. You were right. The slide was wrong. Okay. So question to all. This is probably more straight. Sum and max are commutative and associative. Is that true or false? Yeah, that's correct. That's correct. Yes, that's right. How? Thank you. Great. Now moving ahead. Now, all right. So let's talk about accumulators. All right. I think we should continue tomorrow. All right. Let's continue the discussion tomorrow from here onwards and see you tomorrow. All right. All right. Thank you, Shekhar. Thank you, Arpan. Thank you, Gridhar. Thank you, Shrees. Thank you, How. Have a great day. Bye bye.